Okay, so today we're going to continue with our learning target. I can informally use angles and triangles and parallel lines to establish facts about angle relationships. So we're going to be looking mainly at the parallel lines and then the angle relationships that are formed when we have parallel lines. So parallel lines on their own do not have angles that are involved with them. However, when we include a transversal, that transversal creates those angles, which then in turn creates angle relationships. So what is a transversal? A transversal is a line that intersects two parallel lines. So if we look at our diagram, we see that we have two parallel lines, A and B, and we can see that they're parallel because of these double arrows. That lets us know that A and B are parallel to each other, and they are intersected or cut by the transversal, which is this line here. And when that happens, we have 8 different angles that are formed. And with those angles, we're able to make assumptions on their angle measure based off of some different facts that we're going to talk about in just a moment. So the first angle relationship that we're going to talk about is referred to as vertical angles. And vertical angles are angles that are opposite each other, that share the same vertex. And these angles are going to be congruent. And they are congruent by the transformation rotation. So if we look at our diagram, I'm going to focus primarily on this vertex for now. If I look at 1, 2, 3, and 4 in my angles, angle 1 is opposite angle 3. So my vertical angles are angle 1 and angle 3. And so I can say that those two angles are congruent. They are the exact same measure, because if I were to use my patty paper and trace angle 1, it would be the exact same measure as angle 3. Using that same vertex, I can also see that angle 2 is opposite angle 4. So angle 2 and angle 4 are also going to be congruent via rotation. If I move to my second line, I have a second vertex right here, and angle 5 and angle 7 are opposite each other. So angle 5 and angle 7 are going to be congruent. They're going to be the exact same measure. And then same with angle 6 and angle 8. Those are opposite each other. They share the same vertex, and they are also going to be congruent. So to signify that, you might see a single arc on 8 and a single arc on 6. And then maybe on 5 and 7 to show that they are congruent, we might have a double arc on 5 and 7 to show that they have the exact same measurement as well, or that they are congruent. Our second angle relationship that we have is called corresponding angles. And these are angles that are in the same position, but on the next parallel line. And it creates kind of an F pattern. So if I were to look at my parallel lines, if I can draw an F, I'm going to highlight this a little bit more. If I can draw an F, corresponding angles are going to be in the same position, but along each of the parallel lines. So angle 4 and angle 8 are both in the armpits of my F pattern, therefore they are corresponding. So angle 4 and angle 8 are corresponding angles. And the corresponding angles are congruent. And the transformation that allows them to be congruent, if you notice, they didn't turn, they didn't flip, the angle just moved down. So therefore they are congruent by translation. So if I wanted to find another set of corresponding angles, I'm going to look for another F pattern. So I could use the transversal and create an upside down F. And that would allow me to see that angle 1 and angle 5 are also in the same position on each of the parallel lines, which means that angle 1 and angle 5 are corresponding angles and therefore are also congruent. I can then draw a backwards F, which allows me to see that angle 3 and angle 7 are both in the armpits of the F, therefore they are also congruent and they are corresponding. And then last but not least, I could draw an upside down backwards F, which would allow me to see that angle 2 and angle 6 are also in the armpit of that F. So angle 2 and angle 6 are corresponding angles and therefore are also congruent. Our third angle relationship is one that hopefully you've experienced before or encountered before. It's supplementary angles. And supplementary angles are two angles whose sum is 180 degrees. So two angles that you put them together, they equal 180 degrees. And they look like a straight line. So angle 1 and angle 2, that would be what a supplementary angles would look like, those two. So if I look at my diagram, A is a straight line. And so I can see that angle 1 and angle 2 are along that straight line. Therefore, angle 1 and angle 2 are supplementary. So angle 1 plus angle 2 will equal 180 degrees if I were to add them together. If I look below my parallel line A, I can see that 3 and 4 are also along that same line. So angle 3 plus angle 4 is also going to equal 180 degrees. And if I jumped into line B, I can see that angle 6 plus angle 5 also are going to be 180 degrees. And angle 7 plus angle 8 is going to equal 180 degrees. Now, there are more supplementary angle degrees because we can use our transversal as a straight line. So if we look at our transversal, on this side of the right of the transversal, I have angle 1 and angle 4 together are going to be supplementary. So angle 1 plus angle 4 are also going to equal 180 degrees together. So then 2 and 3 will also be supplementary. Angle 2 plus angle 3 equals 180 degrees. If I jump down to my second set of angles, 5 and 8 are supplementary. So angle 5 plus angle 8 equals 180 degrees. And then my last set of supplementary angles would be angle 6 and 7. So angle 6 plus angle 7 also equals 180 degrees. So there are lots of sets of supplementary angles within two parallel lines cut by one transversal. Alright, our next set of angle relationship, or our next angle relationship that we're going to talk about is the alternate interior angles. And so with alternate interior angles, you need to understand a little bit of vocabulary. So when you see the word alternate is going to mean opposite. So when we're looking at our relationships, we are looking for angles that are on opposite sides of the transversal. And then our second vocabulary word is interior. And if you think of interior of a house, that means inside. So we are looking for angles that are on opposite sides of the transversal, but that are also inside the parallel lines. And this angle relationship also creates congruent angles by rotation. So for this, since I'm only interested in interior, I'm going to be focusing on the angles that are inside the parallel lines. So for this angle relationship, we are not interested in angles 1 and 2, and we are not interested in 7, 8. We are only interested in the angles that are inside the parallel lines, interior. So that leaves only 4 angles that we can work with. So with alternate interior angles, they need to be inside the parallel lines on opposite sides of the transversal. So if I am focusing on angle 3, that is on the left side of the transversal. If I am looking for an angle that is on the opposite side of the transversal, I need to look, and that is congruent, and congruent by rotation, that is going to lead me to angle 5. So angle 3 and angle 5 are alternate interior angles and are congruent. That would leave angle 4 and angle 6 to then also be a set of alternate interior angles. They are on opposite sides of the transversal inside the parallel lines. Now when I was taught this, my teacher taught me to look for the Z. So if you look for a Z, the angles that are inside the armpits of the Z, I guess it would be inside the armpit and the kneecap, or inside the knee, those are going to be your alternate interior angles. And because this is math and our letters don't necessarily have to go the same way, we could also create a backwards Z. It's a little funkier looking. Okay, but then we can see that 4 and 6 are also going to be congruent. So that's alternate interior angles. We then have a set of angle relationships that are called the alternate exterior angles. An alternate, as we discussed, means that you're going to have angles on opposite sides of the transversal. However, this time we're going to be looking at the exterior angles. And if you think again of exterior of a house, that is outside. So alternate exterior angles are going to be found on opposite sides of the transversal outside the parallel lines. So if I have my parallel lines, I'm going to highlight those. And I'm only interested in the angles that are outside of the parallel lines. Means I'm not going to be looking at 3 and 4. I'm not going to be looking at 5 and 6. So that means that 2 is on the left side of the transversal. So opposite that is going to be angle 8. So angle 2 and angle 8 are alternate exterior angles. And very similar to alternate interior angles, these are also going to be congruent by rotation. So if 2 and 8 are congruent, that would leave angle 1 and angle 7 to be alternate exterior angles and also congruent. So angle 1 and angle 7. All right, and our last angle relationship is consecutive same side interior angles. So consecutive basically means same side. It's going to be on the same side of the transversal. So consecutive means same side of the transversal. And then interior, as we talked about already, interior means that it's going to be inside the parallel lines. Okay? And now these angles are going to be a little different because they're not going to be congruent. They are going to be supplementary, which means that they are going to add to 180 degrees. So if I am focusing on my parallel lines, and I am interested in the interior angles, so I'm not going to focus on 7 and 8. I'm not going to look at 1 and 2. If I start with angle 3, if I am looking for an angle that is on the same side of the transversal inside the parallel lines, that would lead me to angle 6. So angle 3 plus angle 6 is going to equal 180 degrees. And then angle 4 is on the same side of the transversal as angle 5. So we would say that angle 4 plus angle 5 is equal to 180 degrees. Okay, so that was a lot of information that we just covered. So how can we actually use these angle relationships to help us when it comes to types of problems? So our first example says, find the measure of all the angles if the measure of angle 1 is equal to 60 degrees, and explain how you know. So if I look at my diagram here, the problem tells me that the measure of angle 1 is 60 degrees. So I'm going to label angle 1 as 60 degrees. So I can do this a couple different ways. I don't necessarily have to start with angle 2. I might just use the angle relationships that I know. So right off the bat, the angle relationship that sticks out to me, I see a shared vertex, and I see two angles that are opposite each other. So the angle relationship that 1 and 3 have are vertical angles. And I know, if I look back at my notes, that vertical angles are congruent. So since vertical angles are congruent and 1 and 3 are vertical to each other, that means that the measure of angle 3 is going to be 60 degrees. And I know that because of the vertical angle relationship. They are vertical angles to each other. Vertical angles are congruent. That's how I know. Okay. Then, if I need to figure out angle 2 and 4, knowing that 1 and 3 are congruent, that's helpful, but 1 and 2 are very visibly not congruent. So I have to think, all right, what relationship has two angles that are right next to each other? And if I notice, they're along a straight line. So looking back at my different relationships, I can see that supplementary angles are two angles that fall on a straight line and add to 180 degrees. So to figure out angle 2, if I take 180 degrees and I subtract 60 from that, I will get the measure of angle 2, which is 120 degrees. And I was able to find that, or I knew that, because angle 1 and angle 2 are supplementary angles. Okay, and once I know angle 2, I'm then able to figure out angle 4, because again, 2 and 4 are also vertical angles, so that means that 4 is also going to be 120 degrees. But not because of supplementary angles. I discovered that, or I said it was 120 degrees because I was using the vertical angles relationship. And I know that vertical angles are congruent. Now, you could have also explained that had you done angle 1 plus angle 4, or 180 minus 60, you could have also said supplementary angles for that explanation. So with this unit, or with this topic specifically, your explanation might be different from a friend because you might have gone about solving the problem in a different method, and that's okay. All right. So now, in order to jump to the second parallel line and look at this group of angles, I need to look at what angle relationships allow me to look at an angle on one parallel line and then compare it to an angle on the other parallel line. So if I look at my angle relationships, that would include either corresponding angles, or alternate interior angles, or alternate exterior angles, or even consecutive angles. So if I'm looking for angle 5, let me start with angle 5, I can see that angle 5 is consecutive with angle 1. So angle 1 and angle 5 are congruent, which means that angle 5 is going to be equal to 60 degrees because of, I said corresponding, I meant, no, I said consecutive, I meant corresponding. So because of corresponding angles, and corresponding angles are congruent, which is why angle 1 and angle 5 are the same measurement. And then once I figure out 5, I can use alternate interior angles, I can use many different angle relationships. However, I'm going to stay simple and follow the same pattern that I did with my top group of angles. So 5 is vertical to 7, which means that 7 is also going to be 60 degrees because vertical angles are congruent. And then I can solve for 6 or 8, and I can do 180 minus 60 again, and that has not changed, so angle 6 is equal to 120 degrees by supplementary angles. And again, those are not congruent. Those are adding to 180. And then because angle 6 and angle 8 share a vertex and they are vertical to each other, I can see that angle 8 will also be 120 degrees, and that is because vertical angles are congruent. Now again, there's many different ways that we could have solved those using different angle relationships. You just have to pick which ones make the most sense. So if you have specific angle relationships that really make sense to you, I would do your best to try to work with those first before you go to the ones you're less certain of. So example 2, I'm given two angles and I'm asked to find the value of x. So looking at the relationship, I can see that between my parallel lines, they are inside my parallel lines on opposite sides of the transversal, and I can see kind of a Z pattern, which means that these are going to be alternate, because they're on opposite sides of the transversal, interior, because they are inside the parallel lines, angles. And if we look back, we know that that means that they are congruent or equal. So to set up my problem, I'm going to take the value of one angle, 3x plus 10, and set it equal to 5x minus 10. And then I'm going to solve like I would any equation. So go ahead and do that right now, pause the video, and when we come back, you'll be able to see what the answer is and check your work. Okay, so hopefully you can compare your work. After you solve, you simplify, you combine like terms, you got x equals 10. And that satisfies the question. Now just to be aware, that does not mean 10 degrees. That just means the value within the angle to help us solve for the degree measure is 10. And even though it did not ask for it, I did include what the angle measures would be, just so that if you did get a problem that asked for it, you would understand that you're going to take that 10, substitute it back into the expression that represents that angle, and then, again, just solve for that angle degree. Now, on your homework, I want you to go through. I understand that this is a lot of information. This is a very long video. I need to see that you've attempted this so we know where to start. If you have questions and you're not understanding a specific thing, I want you to write it down in this space on your homework so that we can go over those specifically when we get together in our groups to go over the answers to this. Okay, good luck. Again, I should see that you attempted it. I understand you might not fully understand yet, but I need to see where those questions begin. So good luck, and we'll see you later.